So, question 91, a shady looking region, if ever I've seen one. Let's see if we can find out what its area is. So here's the question, the region I'm trying to find. I can think of a couple of ways of going about this, which would be fairly obvious. One of which would be to calculate the area between the line and the curve, this area here, and then subtract the area beneath the x-axis. That would be one way of doing it. But what I'm going to do is to find this point of intersection and treat this as a triangle. So I need to find the points of intersection between the line and the curve first. So this point of intersection and this point of intersection come by simultaneous equations from this y equals x squared minus 4x here, and rearranging that, y equals minus a half x. So x squared plus 4x equals minus a half x gives me the two values of x at the points here, P and O, x equals 0 and x equals minus 4.5. So what I want to do is I want to find the area of this triangle here, from O to P to this point Q, and then I'm going to subtract that area there. So I need to know where the curve crosses the x-axis. So, before that I found the y value of the point P. So putting x equals minus 4.5 into, well, either of these two equations here will give me the value of y of 2.25. So now I'm going to find out where the curve cuts the x-axis, and factorising x squared plus 4x gives me x times x plus 4. So the curve cuts the x-axis at minus 4, 0. So I can now find the area of this triangle OPQ, and a half times the base times the height gives me 81 over 16. And then find the area of the this little section here, which is the integral from minus 4.5 to minus 4 of the quadratic, which gives me 13 over 24. And then the area of the shaded region is 81 over 16 minus 13 over 24, 217 over 48 square units. So that's the way I've answered it. As I mentioned at the beginning, there's a different way. In fact, there are other ways I can think of as well of going about it, but that's the way I've chosen to do it.